Hello guys, it's Juan, and today I'm going to be guiding you guys through question number 17 on the midterm. So for question number 17, we are given three things. We are given the summation from n equals 1 to infinity of 1 over n squared times sine of pi over n, and the summation of n equals 1 to infinity of n plus 1 times 2 to the n over n factorial, and 1 over pi plus 1 over 2 pi plus 1 over 3 pi plus 1 over 4 pi, ... And it's asking us for which of the following series are convergent. So to figure out convergence, we're going to first look at one by one and see which of these converge. And so when looking at the first one, we see an 1 over n squared. And so because of that, we know that 1 over n squared converges because of the p series. So we can say that converges because of p series. And so the next tricky part is when looking at the sine of pi over n. The limit of pi over n as n approaches infinity is equal to 0 because it's going to be a small number over a really, really large infinite number. And because of that, it's going to kind of cancel out the sine of pi over n, and thus making our only notable appearance, the 1 over n squared. And so because of that, we can say number 1 is convergent. So we can say 1 is convergent. And so now let's look at this next one. So the n plus 1 times the 2n over the n factorial. So when looking at this, I don't know what I can do, but the best test to use in this case is going to be the ratio test. So let me move over here. So I'm going to write out n plus 1 times 2 to the n all over n factorial. And so I'm going to use the ratio test on this. So the ratio test says the limit as n approaches infinity, the absolute value of a of n plus 1. So I'm going to plug in n plus 1 to all these n's here. So when I plug in n plus 1 to n plus 1, I'm going to have an n plus 2. So an n plus 2 times a 2n plus 1. But when I have 2n plus 1, I can just separate that 2n times 2, because when you're multiplying exponents, you're actually adding them. So then I'm going to have a times 2n and times a 2 all over a n plus 1 factorial. And same thing here. When I have n plus 1 factorial, another way to write this one out is n plus 1 times n factorial, because n factorial, or factorial, is the term you start with and then you multiply it by the term, like the next term that's minus 1, so on and so forth. And the term when you subtract 1 from n plus 1 is just n, so that's why we can say n plus 1 times n factorial is equal to n plus 1 factorial. So I can write that out here, n plus 1 times an n factorial. And so we're going to have to multiply this all times our original equation. So times our n plus 1 times 2n all over n factorial. Actually, this is going to be divided by. And so when we copy dot flip this, we're going to be able to cancel out our n factorials, our 2n's, and our n plus 1 and our n plus 2 on top. And so because of that, we're going to be left over with an equals of absolute value of 2 over n plus 1. And so if we wanted to know if it converges, it has to be less than 1. And so since we're going from n approaches infinity, we're going to have a very small value over an infinitely large value on the bottom. And so small over big is going to be like close to 0. So we can, since 0 is less than 1, we can say this converges. So over here, we also have 2 converges. So now, let's look at the last one. So they don't give me a series, but we do know we're adding something. So we know the summation from n is equal to 1 to infinity. So by looking at this, I see that my 1 over pi is is always constant. I always keep that. But the one thing is I'm always having a bigger value. So I know my 1 over pi is constant. But I have a 1, then a 2, then a 3, then a 4. So that's an easy equation to find. That's 1 over n pi. And so when doing this is a very simple thing. We're going to do the limit comparison test to the harmonic series of 1 over n. And because 1 over n diverges, then 3 just diverges. So then our answer for which of the following series are convergent is just 1 and 2. And so that's the answer to question 17. And so now I'm going to give you a couple questions that are similar to it and see what you think the answer is. So the questions are here. If you want to pause right here, go ahead, do your attempt, and then I'll show you what the answers are. Okay, now that you've come back from the pause, it's time for me to show you how you can go about solving these. So it's going to be the same concept of you're solving which of the following series are convergent. And so because of that, we are going to look at our things and see what we can do. So our first one is just n factorial over n squared plus 1. And so you might think that we might need to do the ratio test, but we actually don't. We can just say, because of the nth term test, it diverges. And you might be confused why I could just look at it and say that. But it's because n factorial is a really big value. So for example, if we had 10,000, it'd be 10,000 times 9,999. And then so forth, so on. And then the bottom is going to be 10,000 times 10,000 just squared, which is not as big as 10,000 times 9,999, 9 times 9,998, and going forth. That's a really big value. And so because of that, since our nth term is approaching infinity, we can say this diverges. So we know 1 diverges. So now let's look at the next one. And so some people might be inclined to say this converges because of this part right here. They look at it and they say, okay, this looks like geometric. Geometric equations typically do converge, but in this case, they don't. If it was just the 2 over 3n, in this case, we could use the a over n over 1 minus r to figure out what our value sums up to, or we can just say it converges in this case. But because of this n in the front, it complicates things because we're going to be multiplying by a value, making our values keep on increasing or stay at a steady rate. And so because of that, I can also again say because of the nth term, we converge. And so then now that we figure that out, we know that 2 diverges, not converges, it diverges because of the nth term test, because it's going to be going to infinity. And so this next one I did was try to trick you guys up, because I know in most cases there isn't a plus or a minus, and so because of that, I wanted to add it here and see what you guys think. So some people, they might not know what to do, but that's why I'm going to show you guys how to do it. So in this case, there's a plus, but I'm not really going to care about it. I'm going to separate these things. I'm going to tackle them one at a time. And so we know what 1 over n squared does. We know it converges because of the p series. That p is greater than 2, p is greater than 1, which means it converges. And because of that, I can just say, this converges because of p series. Okay, cool. Now I look at negative 1 n times n. If it was negative 1 over n to the n, I could say it converges because of the alternating series, since it's alternating values that are decreasing in value. But for this one, the n is being multiplied to our negative 1 over n. And so that's getting really big values that are alternating. And so because of that, we can say it's diverging because of the nth term test, since our values are going to infinity. And so now Now we can take the plus into consideration. A convergent value plus a divergent value will always be divergent, because no matter how much you add to a divergent value, you will always get divergent. So because of that, we can say 3 is divergent, and so therefore none of these would be convergent in this case. That's my video for question number 17 on the midterm and a problem similar to it. Thank you for watching.